Okay, this will be our last coding session. In the next one, I will present you what we built and some reflections about that, some thoughts about that. But in this time, I will start by creating our face detector view model, which will be in charge of a bridge, like a bridge between the UI and the data layer. So the face view model will be injected with the face analyzer repository, and this is responsible for the actual face analysis. Here we can see this UI state, and this is a data class. I mean, this UI state variable represents a data class that holds all possible states our UI can be in. So it's necessary to identify all the possible UI states the screen could be. For example, when a face is recognized, we want to show to the user the name of the person what the face belongs to. So that is the case where we can use the recognize state. Also similar but opposite is the unknown or known state, which is the default one. So what we want is to expose these UI states to the view, to the activity, in a way that the activity could show to the user the last updates. So the first function we are going to build is in charge to analyze the face image. This is the name of the function as well, analyze face image. This is where the action starts. We pass in a bitmap image and of it goes to the repository for analysis. Any error in the recognition is caught and the UI state is updated to an error state. So in that way, we ensuring the user isn't left hanging forever. In the same way as we did before, we can construct that state here, passing as parameter an error message. The response is a person model, and we need to do some logic here because we want to determine if the person name is unknown, then the UI state is updated to reflect that the face is unrecognized. But otherwise, if a name exists, then it means we have recognized the person, so we need to update the UI state to recognize. So we here are setting the UI state status as recognized. We are done with this function. Let's continue with the last one. Save new phase. An autoexplanatory function. And this function allows us to store new phases. If the phase is successfully saved, we reset the recognition state to idle because this ensures that the app free resources that we are no longer using. Errors here are gracefully handled similar to our analyze image function. So the resources are free when we call the function onResetRecognitionState. This reset the current state to recognition state and idle, allowing for fresh interactions. We are done with the view model. Now we can follow with our main activity. Now in the main activity, the first thing to do is create an instance of the view model we just created, because this will allow us to observe the UI state change that happens. In the onCreate method, it's time to create the function to observe the UI state. This function is responsible for monitoring changes in the UI state, which are encapsulated in the UI state variable in the view model. And this function evaluates the recognition state contained in the UI state to determine the application's subsequent actions. So, in order to handle all different scenarios, all different states, we create this function handle UI state. The first state to handle is the idle state. When the idle state is present, it's time to call the function startPhaseDetector. This function manages the initiation, and resumption of the phase detection engine. It uses a handler to pause a delay task, effectively debouncing the process to prevent overloading the system with frequent restarts. And once invoked, it signals the phase detection instance to begin analyzing new camera feed data again. The next one is the recognize state. Upon successful face recognition, the show person name function will be responsible for providing user feedback. So the feedback we are going to provide to the user is show a TOAS message, and utilize a text-to-speech engine to audible greet the recognized person by name. After the acknowledgement, the face calls a star face detector to continue the face analysis process. Now, when the system detects an unknown face, the show name input dialog functions come into play. This function requires display a dialog with the face that wasn't recognized. And this involves a hard work and not necessarily related to the core of these videos, which is machine learning and applied to face recognition systems. So we are going to save some time just copying and paste the source code for the dialog where the user will be able to enter the identification of the face image. I mean, an identifier and a name which represents the name of the person um, in the image, of course. So this is the UI. This is how the dialog will look like. Now let's do the same for the class implementation. Just copy and paste. It's important, but not the core of this record. So just copy and paste. Delete the unrecognized libraries. Re-import the resource. Okay, with that done, it's time to come back to the function. And here, instead of passing the bitmap image directly to the fragment through a bundle, for example, this is not practical for things related to memory and yeah, amount of size of resources we can pass in a bundle. So for that reason, we create this function save bitmap to temporary file. This is a utility function used for saving a bitmap image into a temporary file within the application's cache directory. And this method is particularly useful for storing an image that will be using or sharing by different components of the application. Because basically in the fragment we will retrieve this bitmap from the cache instead of directly retrieving it from the bundle. Now we are setting up the listeners. When all the data for the user is entered, we need to interact with the view model in order to save this new phase. Or if the process of saving the image is cancelled, then we need to reset the recognition state. And basically that's it. It's time to delete this command code in the onFace cropped and call the analyze face image. Now almost all the puzzle pieces are in order. Lastly, when the state is error, we need to do the same. I mean, we need to handle this state. In order to do that, let's create this show error dialog, which will create a generic dialog in order to display a message error. And of course, let's handle the non-state. We don't need to do nothing there. Okay, we are done. But let's check some aspects we're missing in previous videos. For example, here in the crop face bitmap, in the face detection, here is coarse at most instead of coarse at least. So this is pretty important in order that the bitmap is displayed in the dialog in a proper way. In the graphic overlay, after in the set camera info, remember to pause invalidate. Yeah, basically these two corrections are the only ones, so we are ready to test our application and see everything in action.